In this lesson, we're going to discuss global winds and weather and what causes these. Of course, the ultimate cause of the wind and other weather on Earth is the sun and how the Earth receives energy from the sun. Remember, the region near the equator receives the most energy, while the poles receive the least. So the air around the equator tends to heat more than the surrounding air. This causes it to move upward, away from the surface. I'll illustrate this air movement at both edges of my picture, but understand this actually occurs all along the equator. When the air reaches the tropopause, it tends to diverge to the north or south, and somewhere around 30 degrees north or south latitude, the air has cooled enough to begin sinking toward the Earth's surface. It is there that those sinking air masses diverge, moving to the north or south. This movement creates a circulating mass of air that meteorologists call a cell. At the poles where the Earth doesn't receive as much solar radiation, the air tends to be colder, and the air masses sink downward toward the surface. Again, this air diverges, moving southward or northward toward the equator. This air eventually collides with another air mass at about 60 degrees north or south, where the air is forced upward. It diverges and creates more of these cells. The Earth, with all of its moving air masses, has areas that tend to have high pressure and other areas that tend to have low pressure. Wherever you find air masses moving up, away from the surface of the Earth, there will be low pressure. Like here at the equator, and here at 60 degrees north or south. And where you see the arrows point down toward the surface of the Earth, these will be regions of high pressure. At 30 degrees north and south, and at 90 degrees north and south, we'll find these areas of high pressure. These different pressure zones on Earth have names. At the equator, we have the equatorial low pressure zone. At 30 degrees north and south, this is called the subtropical high. And at 60 degrees north and south is the subpolar low. You can probably guess a logical name for the pressure zone at the poles. Right, it's called the polar high. The next pattern that we'll look at is that of moisture. Remember, if the pressure is high, it's going to be dry. But if the pressure is low, you may get snow or rain. You see, they rhyme. High and dry, low and snow or rain. So knowing the pressure zones allows us to predict the moisture patterns on Earth. At 30 degrees north and south, the pressure is high, so it tends to be dry. We live near 30 degrees north latitude, so it's not too hard to fathom that we tend to have dry conditions. However, you may be surprised to discover that the poles also tend to be dry. Though there's snow at the poles, it doesn't frequently fall. The snow that's there has probably stayed there for a long time. So how about near the equator in the region called the Tropics? This region is characterized by low pressure, and if the pressure is low, you may get snow, or in this case, rain. And that doesn't come as a surprise that you should find lots of rain and even tropical rainforests or jungles near the equator. The other latitude that frequently gets precipitation is at 60 degrees north or south. Next, we'll add some more arrows to our map to show the wind patterns that exist all across the Earth's surface. Now, if you're taking notes with me, don't draw in these next arrows because they're not quite accurate. So at 30 degrees, I'm going to show the movement of air all across the globe by using these blue arrows. And we see the same thing in the southern hemisphere, with air moving northward and southward. Then near 60 degrees north, we can show the air moving southward, and at 60 degrees south, we have air that's moving northward. But don't draw these arrows yet. We've forgotten one important idea. Remember, these winds are all subject to the Coriolis effect, which is caused by the Earth's rotation. In the northern hemisphere, the Coriolis effect causes the winds to veer off course toward the right. And in the southern hemisphere, this is reversed, so the winds veer off to the left. This is a little tricky to illustrate on this drawing. In the southern hemisphere, I'll draw these arrows curving off to the left. In the northern hemisphere, these arrows will curve to the right. But you have to imagine that you're on this arrow. So imagine following this arrow and slowly turning to your right. When I draw this, it looks like the arrow turned left, but from the arrow's perspective, it's veering off to its right. So we'll draw arrows right here, all turning to the right. Then at the northern mid-latitudes, I'm going to curve these arrows off to the right. And up near the North Pole, I will again turn my arrows toward the right from their perspective. Now I finished drawing the arrows in the southern hemisphere, turning them toward their left. Okay, let's get rid of those other arrows that didn't take into account the Coriolis effect. So we see some global wind patterns that we can describe and name. These large-scale winds are known as the prevailing winds, and they tend to dominate the winds in an area. Of course, that's not to say that you can't have local winds with different tendencies. So near the equator, you can see that the tendency is for winds to come from the east and blow toward the west. Because of their importance to early shipping routes, these became known as the trade winds. Since winds are named by where they originate, we can be even more specific with these names. Those winds just above the equator come from the northeast, so they're called the northeast trade winds. And the ones south of the equator, you guessed it, those are the southeast trade winds. How about the winds between 30 and 60 degrees latitude? Those winds are called the Westerlies. And the winds near the poles that come from the east are called, the polar easterlies. You see, occasionally terms in science do make sense. Okay, so if you're just north of the equator, you likely will experience winds coming from the north and east. And if you're south of the equator, you tend to experience winds coming from the south and east. But what if you're in between? What if you're in that region that's known as the Intertropic Convergence Zone, or the ITCZ? It's here that air tends to move upward, not across the surface. This means if your sailboat was here, you'd be out of luck and probably feeling pretty depressed. Maybe why this region is known by sailors as the doldrums. Similarly, at the region near 30 degrees north or south, the air tends to move downward, not side to side. This creates another area of calm, known to sailors as the horse latitudes. There are some interesting explanations about the origin of this name, and I'll let you do your own research on that. Okay, so let's summarize these patterns that we've illustrated on this map while making a little key. We first looked at the pressure zones caused by rising and falling air. Next, we looked at where the Earth tends to receive moisture and how this relates to the pressure. And finally, we labeled the tendency for air to move across the Earth, or the global wind patterns. Don't forget that the cause for all of these patterns is the differential heating of Earth caused by the sun. So now you can use your global weather pattern map to help explain the weather that occurs at different latitudes on Earth.